Hello everyone, I am Nitin Yadav, R&D engineer at Logic Fruit Technologies, and today I'll be giving demo of Logic Fruit Technology JESD204B IP core deterministic latency testing using Efinix eval board using TI ADC. In this demo, we have two eval boards. First one is the Efinix eval board, which have a titanium FPGA from Efinix. Along with that, on the board we have a 512 MB of NOR flash, which we used for MCS loading and configuration purpose. And the configuration is done through USB Type-C cable, which is connected to the host PC. And on the second eval board, this is our TI ADC eval board, on which we have our TI ADC AFE58JD48, on which we have a 16 channel ADC inputs, and on the ADC we have two JESD204B dies which will capture the data from 8 channel each, and we are using one die of that, and that die is processing the data of 8 channels and then sending the digital data to the FPGA through this FMC connector. The Efinix eval board have two HPC FMC connectors, and we are sending data through one of that. And on the ADC eval board, along with that, we have a LMK chip, which is a clock generator which is generating device clock and sysref and ADC sampling clock as per the JESD204B protocol. So in the setup, we have mainly 3 cables. First 2 cables are for the data generation. On that, one of the cable is used for the ADC input. We are generating 2.44 MHz of data through LMK itself, the synchronized data, and we are sending that to the ADC input channel 0. Along with that, we have one more cable which is generating 2.44 MHz output, which is also generated by LMK in a synchronized way, and that is being mapped on the oscilloscope for reference to check the deterministic latency. Along with that, we have one more cable. So what it is doing is our ADC is sampling the data, digitizing it, sending it to the Logic Fruit Technologies JESD204B IP core, and our IP core is processing the data, and the captured samples MSB bit is being sent to the ADC again through one GPIO, and we are capturing that MSB bit on the oscilloscope. So if you check on the oscilloscope, we have two waveforms. And the yellow color one is the waveform that we are generating from LMK. That will be given to the ADC input also. So these two outputs will be synchronized, and this is of frequency 2.44 MHz. And the ADC will be sampling this waveform, sending it on JESD204B interface, and then our Logic Fruit Technology IP will be capturing this data and then sending that MSB bit. And this blue color will be the MSB bit that we are capturing from our deframing outputs. So if you check, the rising edge to the rising edge delay is always constant. Even if we power cycle the board multiple times, then this rising edge to rising edge delay will always be 234.4 nanoseconds. So that proves our deterministic latency. And also on the frequency side, if you check, like the input frequency is 2.44 MHz and the captured frequency is also 2.44 MHz. So that means we are capturing our data efficiently. So yeah, this is the demo that proves our deterministic latency.
Hi everyone, my name is Pratik Singhal and I am an R&D engineer at Logic Fruit Technologies. Today I am going to present the demo of deterministic latency feature implemented on Logic Fruit Technologies JESD204B IP core using Efinix eval board and DAC38J84. In this demo, we are using two eval boards. The first one is Efinix eval board and the second one is DAC38J84 EVM. On the Efinix eval board, we have the Efinix titanium chip, and on the DAC board, we have the DAC38J84 chip, as well as a low jitter clock source LMK04828. For the clock source, we are using a 100 MHz external input to the LMK so that we can get jitter-free FPGA clocks, DAC clocks and sysref. The bit file, which contains the logic fruit JESD204B IP core, is programmed through the use of JTAG, which is connected to the other end of the host PC. On the oscilloscope, you can see a yellow colored pulse. This pulse acts as a trigger signal for the block RAM. This block RAM is already programmed with 25 MHz sine wave samples. These samples are given input to the Logic Fruit Technologies JESD204B IP core when the block RAM receives this trigger signal. As a result, since the IP is in data phase, we can view the output, that is the green waveform. Now, we have placed two cursors on the oscilloscope. One cursor marks the rising edge of the trigger signal and another cursor marks the output waveform that is in the green color. Delay between both the cursors is 317 nanoseconds, and this value will be same on every power cycle. Thus, it proves our deterministic latency feature.